I wonder what the derivative of tangent is. Let's use the quotient rule. Let's suppose that our function is, we'll call it h. It's tangent of x. And tangent, of course, cosine, right? I mean, you could say it's opposite over adjacent, but ultimately sine over cosine. So sine x over cosine x. And we're going to do a little bit of stuff in our head. We can write all the f's and the g's out over and over, but I'm not. I'm going to sort of do things in my head here. So knowing that the derivative of tangent, the derivative of h in this case, is going to involve the quotient rule, we'll call this f, we'll call this g, so f prime g, yes, that's cosine squared, f prime g minus f g prime. Well, the derivative of cosine is negative sine, all divided by g squared. There we go. So let's simplify this a little bit, and we're going to have cosine squared, and then negative and negative multiplies, of course, gives me sine squared, positive there, and cosine squared. And we have several things we could do here. I'm going to go for something that personally I think is obvious, and it might not be where your eyes went. Your eyes might have gone to canceling these out, and that works. You'd still have 1 plus tangent squared, which is going to give you the same final answer. So here we go. Cosine squared plus sine squared is 1. See? Sine squared plus cosine squared is 1. Reverse the order. We have 1 over cosine squared. 1 over cosine squared is secant squared. So the derivative of tangent is secant squared. Fun, isn't it, right? Okay, again, if you would have gone about this a different way and said cosine squared over cosine squared is 1, that's fine. And then sine squared plus cosine squared is secant squared. 1 plus secant squared is still, oops, tangent. Ooh, I said the wrong thing. 1 plus tangent squared. Ooh, don't do that. Wow, I was thinking way too far ahead. 1 plus tangent squared is equal to secant squared. It all works out the same in the end. So let's do a similar problem, only we're going to say that we're finding the derivative of cotan this time. Same process, different function. So let's say that h is cotangent of x. I actually recommend that you mute the video and try this one on your own. And so here we go. We're going to have cosine over sine. And so we will do f prime g minus f g prime, all divided by g squared. So f prime g minus f g prime, all divided by g squared. Okay, that gives us negative sine squared minus cosine squared, all divided by sine squared. I see a negative in the top in the numerator that can be factored out. So let's factor out a negative 1, and that'll give us sine squared plus cosine squared. All that is divided by sine squared. Sine squared plus cosine squared is 1. That's going to give us, well, negative 1 over sine squared. Negative 1 over sine squared is, well, negative cosecant squared. Negative cosecant squared. Okay, you will notice a pattern. The derivative of cos are negative. The derivative of cotan is negative. The derivative of cosine is negative. And the derivative of the non-cos, sine, tangent, secant, are going to be positive. All right, we're going to find some other ones in a minute.